In this video, we'll do a revision paper, so there's a good mix of questions from every topic, from pure math and from statistics. So the first question you see, it's actually an integration question. So let's go ahead and do this. If you take a look at this, you might be tempted to use integration by parts, but please don't. Why? Because it's only 2 marks. There has to be an easier way. The easier way would be to make use of, let me just copy down a question. Convert this to power half. Think of this as your fx. You notice that I am able to force this to become f prime x, because what is f prime x? F prime x is negative 2x. So if I put a negative 2 here, I will have to compensate by a negative half on the outside so that I don't change anything. And then, very nice, the inside it's already in the f prime x, fx to the power of half form. So let me just write what I said here. Integrate f prime x, fx to the power of n, we'll get fx to the power of n plus 1 over n plus 1. This will give us negative half fx power plus 1 divided by new power plus c. Clean this up, I'll get negative 4 plus x squared power 3 over 2 over 3 plus c. 2 marks when we're done. Hence, find the exact volume of revolution when the region bounded by the curve. This, the line, and this is rotated completely about the x-axis. When we are not sure what the graph looks like, just go and plot it. You will get something like this. Let me just zoom in. I'm going to paste this here. We are interested in the curve, line x equals to 0, which is the vertical line, x equals to 2, which is this line, and y equals to 3. 1, 2, 3 is probably on top. Here. The region they are talking about is here. This shape is being rotated about the x-axis. So x-axis, we're going to rotate it this way. So 2 options. Integrate pi y squared dx or pi x squared dy. Please make the right choice. The correct answer is the first one and not this one, because look at here, we are using the x as the axis of rotation. So the choice has already been made for you. You don't have to think too hard. If you rotate x, just use the one with dx. Then second of all, think about how do you get this volume that is generated. Now take a look at the blue color part. When you spin this, you sort of get like a the chocolate, the Hershey chocolate. Yeah, you get that kind of shape. Then the volume generated by the red color part will simply be this entire cylinder, the green one, minus away the Hershey looking chocolate shape, right, to give you the remaining red color volume that is being generated. So let's go ahead and do that. This one you don't have to do any integration. Well, you can do integration, but the easier way here would be to use the cylinder formula, pi r squared h. So how do you find out the radius? The radius is this one. Radius would be from here to here. So this is 3, right? So 3 is your radius. What about the height? Height is this length here, bounded by the line x equals to 2, right? So this means that this is value 2. So height is just 2. This one requires this integration. Pi y squared dx from 0 all the way to here. 0 to 2. Second thing you need to fill in, what is y squared? Do you have the equation? The equation is this. What happens when you square this? You will get x to the power of 3, 4 minus x squared to the power of half. So we have now set up the question. The application part of integration is done. We apply integration to find the volume. Now let's just solve this question by hand. How do we do that? First part is linked. you have integrated x root 4 minus x squared. We need to incorporate that into here. This is simple. This is just 18 pi. I'm not going to touch this ever again. Here you get a pi. Look, this, if I were to force myself to integrate this, I can do it by parts, meaning here and here. But that would not be friendly. Part 1, we already did this. So I'm going to split this logically into this manner so that I can use part 1. Part 1, we integrated this. So this means that this has to be your dv dx and this has to be your u. Yeah, because LIAT here wouldn't really work. Both of them are of algebra. So if you choose this x cubed to be your u and choose this as your dv dx, you'll run into a lot of issues since you can't really integrate this properly. Make use of what we already have, which is part 1. Incorporate that here. Then everything else will fall into place. Your u is x squared. This means that your du dx is 2x. And if your dv dx is x 4 minus x squared power half, we already know what's the integration of this, right? Part 1 answer tells us that is negative 1/3 4 minus x squared to the power of 3 over 2. So then using this, the integration by parts will become 18 pi minus pi uv, which is uv minus integrate v du. v du is 2x. I'm going to put the 2x here. I'm going to pluck out the negative 1/3 you see here. I'm going to put it outside. This will give us plus 1/3, and then the inside will give me 2x. You know what? I'm going to take out positive 1/3 so that the negative remains inside. You will see why later. I'm going to put out 1/3. Here you will get negative 2x 4 minus x squared power 3 over 2. Evaluated from 0 to 2, 0 to 2. Why I want to pull out negative 1/3 is because here you have the nice f prime x fx form. 18 pi minus pi negative x squared over 3, 4 minus x squared power 3 over 2 minus 1/3. This will just become 4 minus x squared to the power of new power plus 1, 5 over 2 divided by 5 over 2. 0 to 2 boundaries. Simplifying this, 1/3 and 5 over 2 will give us 2 over 15. Sub in 2, I will get negative 4 over 3 minus 0. So this thing is gone. Subbing in 2 here, oh, it's also gone. So that's great. Subbing in 2 will give us 0. Minus away, now we sub in 0. Subbing in 0 here, this gives us 0. This gives us negative 2 over 15. 2 over 15. 4 to the power of 5 over 2, 32. Simplifying the inside will give us just this, which is 64 over 15. Simplifying this will give us 206 over 15 pi. And that's it for the first integration question. Second question, the Riemann sum question, you have to sum up area of rectangles. So in this case, your total area of rectangles is actually an overestimation because you see all these parts that's jutting out compared to what's actually underneath the curve. So all these little tiny bits of extra stuff that's jutting out will create an overestimation. So if you are unsure of what to do, visit the Riemann sum question from Let's Solve to have a basic understanding of what's going on. Here, they ask you to show that the total area of the rectangles is this complicated looking expression. Oof, that is. But it's okay. Do this systematically. Find out the area of one particular rectangle, the first one, and then we try to generate some kind of number pattern. So area of the first rectangle what will it give us? Length times breadth. What is the breadth? Simple question. What is the breadth? 1 over n. What is the height? The height will be subbing in 1 over n into this graph to find us the y value, right? Once again, 1 over n sub in, you'll find this value on the graph. So the height would be, use this formula, 1 minus e to the power negative 2. What is the x value? 1 over n. That's the first rectangle. Okay, we do not simplify it because if you simplify it, maybe you don't see the pattern later on. Then do the second rectangle once we're done with the first. Second rectangle, this one. Area of second rectangle. Breadth, same thing, 1 over n. What is the height now? The height will be subbing in this particular value into the curve to find this point, right? Subbing in 2 over n inside the equation of the curve. 1 minus e, negative 2, 2 over n. Well, third rectangle, everything remains the same except for this number here, right? This number will be the moving part. Later, we will need this moving part to generate the summation expression. Keep that in mind. So once you're done, we don't have to write the third because it's just this, and then you turn this into a 3. Now the ultimate question now will be, what is the area of the final rectangle? The last rectangle. In other words, the nth rectangle. Breadth is the same. What do I want to sub inside here? I will sub 1 into this expression, right? But we do not use 1. We follow this pattern. If this is 1 over n, 2 over n, 3 over n, 4 over n, 5 over n, 1 will actually be n over n. The reason why I want to do this is because I want to find out this bracket. Let me show you. 1 minus e to the power negative 2, n over n. If I just sub in 1, the pattern breaks. 1 over n, 2 over n, blah, 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 1. It's not very nice. I rewrite 1 as n over n, then you will see the mechanism that's moving. 1, 2, 3, 4, 5, n rectangle, here is n. Second rectangle, this is 2. Third rectangle, this is 3. Now we are done with the hard part, so let's generate the summation. If you're not very comfortable, never mind, just write all of these down. I'll get 1 over n. I'll factorize out all the 1 over n's. The first number is 1 minus e to the power negative 2, 1 over n, plus 1 minus e, negative 2, 2 over n, plus all the way until 1 minus e, negative 2, n over n. This rectangular bracket can be expressed as a summation. This would give us, identify the moving part. The moving part will be henceforth known as r. So we are summing up from r equals to 1 to n. And the expression of what we're going to sum up is 1 minus e, negative 2, r over n. This is the moving part. All good? So when you expand this bracket, is when r equals to 1, this is the first term. When r equals to 2, this is the second term, and so on. Do this algebraically. We're going to manipulate this. I should get something like this. 1 minus away summation of r equals to 1 to n of e negative 2 r over n. This will give us negative 2r over n. What is this item here? Summation of 1 from 1 to n. The term doesn't change, right? There is no moving part here because there is no r here. So every term in the number pattern is just 1, 1, 1, 1, 1. How many of these are there? 1 plus 1 plus 1, n times. So this gives us n. Minus away, what is this one? This, you have to recognize that is actually an GP. Now summation, let me give you something easy. 2 to the power of r. If you were to really list them down, you get 2 to the power of 1 plus 2 to the power of 2, so on until 2 to the power of n, right? From this term, to get to this term, we multiply by 2, right? And then so on, right? So 2 is known as the common ratio, which is what makes this a GP. It's actually very similar, it's just that this is slightly more complicated. This is a nice number 2, this is the ugly number e. This is a nice number r. This is an ugly number, negative 2r over n. Don't worry, just ask yourself, what is the common ratio here? If you're not comfortable, just write out e 2 over n. The next term would be summing in r equals to 2, right? So ask yourself, from here to here, what do you want to multiply by? The correct answer is multiply by e to the power of negative 2 over n. So once you have found this is your golden ticket. This is your common ratio. Once you have the common ratio, it is very easy to sum up a GP, because summation of GP is simply this formula here. A 1 minus common ratio to the power of number of terms in the series divided by 1 minus the common ratio. So here, putting all these into place, what is the first term of this series? First term of this series is e to the power of negative 2 over n. Then 1 minus, what is the common ratio? The common ratio is e to the power of negative 2 over n. Then raise this to the power of n, which just give me e to the power of negative 2 divided by 1 minus common ratio, and then that's it. Now compare with what we have. So let me just bookmark what we need to show here. Take a look at this. The 1 over n on the outside, it's here, so that's done. The n here is done. Notice the inside, slightly different. What they did is they reversed the row of these two and reverse the row of these two. So no worries, just pluck out a negative from the top and push that negative down below. So this leaves us with just this n minus, flip this and flip this. E to the power negative 2 over n, e to the power negative 2 minus 1 over e to the power negative 2 over n minus 1. And we're done with this extremely complicated question.